Sorry about that. Okay, so third step or third application of data science is organization. So another way you can use this data science in business is to identify inefficiencies in processes. So in cases where the volume of data is too high for a human to manually analyze, an algorithm can be written to clean, sort, and interpret it quickly and accurately gather insights. And lastly, next steps. So organizations, financial teams can utilize data science to create reports, generalize forecasts, and analyze financial trends. So data on company cash flows, assets, and debts are constantly gathered, which can be used to manually or algorithmically detect trends in financial growth and decline. Additionally, collecting and analyzing data on a larger scale can enable you to identify emerging trends in your market, track purchasing data, and have search engine queries reveal what products people are interested in. So yeah, making product offerings relevant and ensuring the reliability of supply chains is pretty crucial to organizations that want to keep their customers happy. Awesome. So moving on to the next slide. What sets data science apart from other fields? So data science fuses the fields of statistics, mathematics, and computer science. So it incorporates various disciplines, for example, data engineering, data preparation, data mining, predictive analytics, machine learning, and data visualization, as well as statistics, mathematics, and software programming. Yeah. Okay, moving on, next slide. Why call it a life cycle? So the term life cycle refers mostly to the iterative steps that we take to build, deliver, and maintain any data science products. So although every data science project and team are different, the life cycle provides us with a useful scaffolding to structure our projects with and provides us with tools to use. So these typically revolve around the use of techniques and frameworks to produce insights and predictions from information in order to reach some form of objective. Awesome. So that's all the background out of the way. Let's move on to the actual stages. Okay, excuse me. Okay, so the first step is ideation. So first things first, you can't solve a problem if you don't know what the problem is. And the first step in the life cycle is to have a clear understanding of a problem or a business case you're trying to understand and translate that into a data science problem with actionable steps and goals. So just like any good business or IT focused life cycle, a good data science cycle starts with a well-defined why. So clearly state the problem to be solved, its importance, and define the potential value of the forthcoming project, identify the key stakeholders, figure out the kind of problem that's being solved, and then the techniques required to solve the problem. Awesome. Moving on to the next step, which is data acquisition. So if you've asked the right questions and you have a clear idea of the problem you're trying to solve, you should be well prepared to collect the right data for the job, right? So without data, you've got nothing. So the team needs to identify what data is needed to solve the underlying problem and then determine how to get this data. So collecting data from relevant sources, either in structured or unstructured forms. More often than not, if you're collecting it yourself, then it probably will be unstructured. And that's where this next step comes in, where you need to pre-process it yourself. And yeah, it's called preparation. So moving on, data science is all about working smart and not hard. So this means that in order to produce the right models, you have to properly clean and prepare the data you plan on using. So once you have this data, start exploring it. You need to conduct several activities such as documenting the data quality. This means taking note of any anomalies such as like missing values, mismatched values, or like poorly organized or stored data. And then cleaning the data, which involves extracting and transforming the data. So this is where you kind of account for all the problems that you encountered in the previous step. And then you want to combine various data sets to create new views and like kind of figure it out and merge data sets together. And finally, you want to load the data into target data sources or warehouses. And then this is where you want to kind of present any initial findings to stakeholders to kind of solicit feedback and check if you're moving in the right direction. You don't want to have to scrap any of your hard work like any further down the line. Yeah. With that out of the way, we move into research and development. So this is where a lot of the fun begins, and we actually begin to conduct a lot of the analyses on the data. So step one is conducting EDA, exploratory data analysis. This is where you kind of summarize the main characteristics of a data set by developing data visualizations that will help you quickly understand the various features and their relationships. This is also where you want to carry out any hypothesis testing or check any assumptions that you may have or that may have been brought up in previous discussions. And yeah, tools that are typically used in this step include clustering and dimension reduction techniques, univariate visualization, bivariate or multivariate visualizations, summary statistics, K-means clustering, or linear regressions. So those are the common ones. And then you can move on to actually building out your model. So this refers to the process of converting your raw data into a form that can be used to traverse into other applications. So mostly the step is performed in using statistical tools and databases. So this phase of the life cycle is one in which the team works on developing data sets for training and testing, as well as for production purposes. So the execution of the model based on the planning made in the previous phase in EDA is carried out. And then this is also where you want to choose the appropriate model type and learn whether the problem is a classification, a regression, or clustering problems. After analyzing the model family, you have to choose from the selection of algorithms at your disposal to kind of implement. Awesome. Moving on from this, we want to discuss validation and ethics audits. So model evaluation is the process of using different evaluation metrics to understand a machine learning model's performance as well as its strengths and weaknesses. So in case you fail to acquire like the result you're looking for, you have to reiterate the procedures from like the previous steps until you reach a stage that you're comfortable with. And this is typically done in pre-production or testing environments. So although like the model evaluation can be done in parallel, and it usually is done in parallel to the other stages of data science lifecycle, it's important to also have like a checkpoint of sorts to ensure that your model is working as intended at every step, or if you need to make any changes, this singular checkpoint. So yeah. And then finally, for the ethics portion of it, you need to really take the time to think about the implications of this model. Are you being fair, accountable, and transparent? Are our findings reproducible? Do we find that our models add the value that we were hoping that they would? Do they run the risk of harming anybody, or how can we prevent our findings from being misinterpreted? So these are all things you should be constantly asking, or you should be constantly asking yourself throughout the entire process. But like, if you need to have a step, this is where you would probably want to have it. Awesome. Then the final step, which is presenting, deploying, and monitoring. So this is the final stage of the life cycle. And after a rigorous evaluation process, the model is finally ready to be deployed in desired format or preferred channel, and the results are communicated to all of our stakeholders. If we're deploying a product, the model is exposed to real-time data that flows into our system, and outputs are being generated. So we need to constantly ensure that we don't encounter any edge cases, and the model continues to perform as expected. So this may involve at points of retraining the machine learning model, or like adding any new data sources that come in, or taking additional steps to kind of maintain the performance. But yeah, that wraps it up for our life cycle stages portion of the presentation. Now we can finally move on to an engagement activity.
So for this section, we're going to take what we just learned from previous slides, and we're gonna walk through an example from like a case study on Kaggle. And so this case study will focus on this Yahoo stock price data set. So here are the first 10 rows of the data set. And the open column means opening price, which is the price of the first trade when an exchange opens for the day. And high is the highest price, low is the lowest price. Close is the closing price, which means the last price of a trade of the day. And adjusted ADJ close is adjusted closing price, which refers to the price of the stock after paying off the dividends. And volume is the number of shares traded in the stock. So the first step we want to take is to define and understand the problem we're trying to solve. So the question we want to ask ourselves in this stage is, what is the problem we're trying to solve? So in this example, the author asked, what will be the value of Yahoo's assets in the near future? But there are like all kinds of possibility of questions you can come up with. So, for future steps, we will be referencing this question. So the next step, we'll move on to collecting the data. So in this case, we already have our data, but in most of the cases, we won't have the data we need until after we ask our question and we start collecting the data. So what if today the data isn't provided? What are some ways we can collect the data we need? Does anyone have any idea?
Sorry, is this like specific to this like stock price situation?
Yeah, if we want to get the stock price data set, what kind, like from where do you think we can get our data?
APIs?
Yeah, that's one way to collect the data. And next step, we will move on to data preparation and exploration. So, the answer is already on there, but it's okay. So some tasks we can perform in this step, based on what we learned just now, is one of it is data cleaning. So if we get like our data from, for example, like APIs, like we might get like raw data, which is like really messy. And in order for us to like analyze it in order for our future analysis to like be performed more easily, we want to transform the messy data into a format that is easier to analyze. So data cleaning is like a very important step. And also we can combine our current data set with other data sets. So for example, if today our question is about like how might inflation plays a role in like the stock price of Yahoo, then we can look for like data sets about inflation and combine it with our current data set. Or for example, if we want to look at like how does stock prices of other companies might have like an effect on Yahoo stock price, then we can find data about like other companies' stock prices. And we can also visualize the data or load the data into like a target location. So now we have our clean data ready. We want to start our research and development process. So based on like previous information, do you guys have any like assumptions or hypotheses about the data? Do you have like any questions about like maybe like this variable relates to this other variable and you want to like check if there is actually any relationship between the two? So in this example, like the author, he chose to like look at the she chose to look at like the correlation between the adjusted closing price versus like other variables. And this picture shows like the data visualization she uses to check her assumptions. So next we move on to model building. And in this step, we want to ask ourselves, like what approach can we take and what model is best fit for the data. So in this example, the author uses a regression model, and we can see how the data set is being split into train and test data sets. And this test data set will be later used for comparison when we move on to evaluation step. So when we build like predictive models, we should use the training set to build the models and leave the testing set untouched. And after training our model, we will evaluate the model's performance on the unseen data points, which comes from the test set. So now we have our model and we move on to validation to evaluate our model performance. So in this case study, the author uses mean absolute error for model evaluation. So MAE is a measure of errors between paired observations expressing the same phenomenon. For example, in this case is actual data versus predicted. So actual minus predicted. So the closer MAE is to 0, the more accurate the model is. And from this picture, you can see the MAE is 18.09. So that means we have like space to improve our model. So what are some ways you guys think we can improve our model? So
Feature engineering or something like that.
yeah. So one way we can is feature engineering, and also we can like change like different parameters. Like we can like just change different parameters to see if that increases the accuracy. Yeah, so next step, we want to consider our ethical part. So in the real world, a data science project can have real implications in people's lives. So this step is like a very important step to ensure that our data is fair and our results won't be harming anyone. So these are the questions we should ask ourselves, and it's also from previous slides too. So we move on to the final stage of our life cycle of data science project. So after we deploy our model, we should not expect it to run on its own, because over time the model will become less accurate and might run into errors because the world is constantly changing and there can be like unpredictable events happening, like COVID is an example. So it is important to maintain and keep updating our model and our data. And now we move on to our Q&A session.
Any questions for us regarding the life cycle? Any ground that we didn't cover?
Yeah, I mean, like when we do a data science project on our own for like a resume or something, what does it actually look like when we're done? Is it like, should we go beyond just having like a GitHub repo with like a Python notebook and a bunch of like files and stuff? Should it look like something in the end?
Well, it depends on like the individual project you're working on. So some projects like might not need to kind of go through all of these steps. Like it's not a predictive analytics project or a task like that. You're just trying to model something into your dashboard. That's also completely fine. So in that case, you probably won't really need like a I guess validation portion of that, because you're just visualizing data that already exists and stuff like that. But if it is for like a predictive task, you know, definitely try to like go out of your way to kind of like also annotate, explain your code, and tell people like why this is interesting and why you are working on this project to begin with. Like what I guess like sparked your interest. So like have a story to tell when it comes to like, a lot of this kind of stuff. If it's like mostly for the portfolio project or if like it's for your resume and stuff like that. But the project on its own is like going to get you through the door, but like actually being able to talk about it is what's going to actually like get you your position. Yeah. Yeah. Any other questions? That was a good one. Tough crowd. Anybody in the Zoom call have any questions for us? We're friendly, I promise. I guess I'll give it a minute or so. Anything else? Okay, so there's one in the Zoom chat. Are there any opportunities to do some projects in Disc? So is that like the Discord or in discussion or like, oh, okay, so DS3? Sorry, wasn't really sure. Okay, so DS3, yeah, so we do have opportunities every, I think 2 quarters or every year or so that we usually have like applications for. But yeah, aside from like projects, there's also committees for us or for people to apply to and to work on. So for example, I'm in the workshops committee. I'm the head for the committing subcommittee. So I'm in charge of like putting together these workshops and like overseeing a lot of them. And then there's also like board positions and exec also on DS3. So plenty of things to do, including projects in DS3. Yeah, good question. Cool. I think that covers everything, unless I'm missing any questions from the Zoom chat. Definitely feel free to reach out to me on LinkedIn or Joyce. Do you have LinkedIn? Okay,
Yeah.
awesome.
Just answer that.
Yeah, it's just our names, so feel free to look us up on LinkedIn and reach out to us on there if you guys want. But yeah, I think that covers about everything. So yeah, thanks DS3,
Thank you.
like marketing team and the workshops team for helping us put everything together. Yeah, awesome. I'll catch you guys later then.
Thank you, everyone.
Bye.